Welcome back, folks, to another session of mathematics. Now we are in Euclidean geometry, grade 11, cyclic quadrilateral. First of all, before I state the theorem, I want you to know what a cyclic quadrilateral is. Any quadrilateral that has got all its vertices on the circumference of a circle, that quadrilateral is known as a cyclic quadrilateral. All the vertices must lie on the circumference of a circle. Now, number two, you must be able to state and understand this theorem so that you can be able to apply it. Let us state the theorem. The theorem states that the opposite angles of a cyclic quadrilateral are supplementary. Beautiful. Folks, I said, understand what the theorem says. It says very importantly, opposite angles of any cyclic quadrilateral are supplementary. Remember what supplementary means? It means they add up to 180 degrees. Now, if you go to my diagram there, that would mean that angle A plus angle D is equals to 180 degrees. Angle B plus angle C is equals to 180 degrees. How do I know that? It is because A, B, C, D is a cyclic quadrilateral, and the theorem tells me that. Now, when I use it as a reason, I just say opposite angles of cyclic quad. You don't have to write it in full. You just say opposite angles of a cyclic quad. Now, the next step is to prove what we have just said. You will be given a circle with center O and cyclic quadrilateral ABCD. What do we want you to prove? We want you to show us that indeed opposite angles are supplementary. Now, the proof to this theorem, which is frequently asked in the exam, and it is so easy to score marks from. Number one, I would construct, I just say construction. Now, construction, I would just say join O to B and O, sorry about that, O to C. What does this mean now? I go to my diagram, I join the 2 points OB, I join OC. Let's do that. Take my ruler there, draw the dotted line. I have joined O and C. I have also joined B and O. Now, because I produced two angles there, I will name them angle O1 and angle O2. That is also very important. Let me refresh your minds on this. Why do we construct? We construct so that we end up having the previous theorem that we know and we have proved in order to prove a new theorem. Now, if you look at this one, I'll show you something now. If you cover that, you end up having the theorem that you have proved previously that says the angle which is subtended by an arc of a circle at center, subtended by an arc at center, is twice the angle which is subtended by the very same arc at any point on the circumference of a circle. Now, we will use that theorem to prove this one. I will start by saying what I know from my previous basic work. Angle O1 is equals to twice angle A. How do I know this? This is angle at center, which is equals to 2 times the angle at circumference. Next one that I know is, remember now, arc BC is subtending this angle. This is the minor arc subtending angle O1. You have the major arc, which is subtending angle O2 at center, and it is also subtending angle D on the circumference of a circle. That is why we are going to say together angle O2 is equals to twice angle D, folks. What is the reason? Angle at center is equals to twice the angle at circumference. Beautiful mathematics. Now, after this, if you go back to your basic knowledge, I know that you know something about angle O1 plus angle O2 there. Angle O1 plus angle O2, you have just told me that it is 360 degrees. Let me put that down. Angle O1 plus angle O2, you said it is 360 degrees. Now, I want to know, how do you know that? All right? All of you are saying revolution. And I want to say to other folks, revolution in this case does not mean the battle like in history, but we mean that this is the angle around a point, or those two angles are angles around the point. Now, don't think about the revolution like in the Battle of Isandlwana. Okay, look at the 3 statements now. Beautiful statements. I've got O1, I've got O2 there. I've got angle O1, I've got angle O2. I've got angle A, I've got angle D. What am I going to do now? I'm going to put them together with my mathematical super glue. Because I have set angle O1 plus angle O2, angle O1 plus angle O2 is equals to 360, I've said. Now let's look at this. If angle O1 is twice angle A and angle O2 is twice angle D, isn't it that if we add these two, it is the same as adding these other two? That's it. Now, this is so beautiful, and now when mathematics becomes this beautiful, it says to you, cough a little bit to show life. That is why I'm going to take a beautiful mathematical cough and go. That's it. Then, let's move on. There's a 2 there. We can factorize that. Angle O1 plus angle O2 is equals to, we remove the highest common factor, angle A plus angle D. But now, what do we know about angle O1 plus angle O2? We said it was 360 degrees. I'm going to put that there, which is equals to twice angle A plus angle D. From here, because I want to make A plus D, those two angles, the subject of the formula, I'm going to divide both sides by 2, and 2 goes once into 2. You must remember to put angles there. 360 degrees has got 180 degrees twos. Ah, beautiful, beautiful people. The theorem stated that opposite angles of a cyclic quadrilateral are supplementary, and indeed we have proved that. Please folks, be able to state and understand the theorem. Be able to prove the theorem. Number 3, if you can do all those 2 things, you will be able to apply the theorem. I'm signing off after this beautiful cyclic quadrilateral with that beautiful mathematical curve.